All right, Stefan, thank you very much for inviting me here to Eirich in Hartheim in Germany to explore the depth and I almost want to say alchemy, but it's also science,
Yeah.
of course, of mixing for battery slurries. And before we jump into today's topic and really explore what you have shown me and Stefan Eirich also has shown us on the tour, how did you find into the field of batteries?
Yeah, we started here in 2009 as an R&D project when the first wave of lithium-ion battery support from the government swept over to Germany. We was, let's say, active in the field of lead-acid batteries, very successful, and we was in fear that we are losing a business. And so we started as an R&D project, was visiting at this time ZSW in Ulm and Professor Winter in Münster to learn about what are the needs of lithium-ion batteries. And this was my starting point to jump into this field of application, which was quite new for us at this time.
So you're saying
Huh?
2009, right? And lead acid. So that was the sparking point.
Yeah. Lead acid, we, let's say, invented the EVAX film process in 1985 around, which is today the standard in the world to make good lead acid batteries, AGM batteries with start-stop systems, for example. And the EVAX film process was, let's say, a special cooling process, so making an atmosphere inside of the mixing process, allowing to take out the heat of an exothermic reaction and to control the, let's say, crystallization process within the mixing process by temperature control. And the temperature control was made by pressure under vacuum. And this was so innovative at this time that we became the world number one in providing technology for lead acid battery preparation.
Okay, so meaning on the slurry side also, so material
Yeah,
preparation, or was it a different? Because
it's
for
not.
those who are not familiar with lead acid batteries and their production, it may be worth elaborating.
It's not really a slurry, but it's a high solid content, let's say, paste. So typically what, let's say, the lithium-ion battery slurry is in between, solid content around 85, 90%. So, and this is, let's say, this paste is pasted into a grid, which is then part of the battery.
Okay, understand.
But quite similar. And so we transferred our know-how from this technology then later on into lithium-ion battery application.
So you're a well-known expert in terms of battery mixing, and I would like to reflect on that. So what is your role in this movement of Eirich into the field of batteries and battery slurry manufacturing? And yeah, your role here in Hartheim. So maybe you can shine light on that really quick.
So I started 28 years ago here at Eirich as a process engineer. Was taking over responsibility as head of process technology in 2002, and was always dealing with the more complex processes, not just a simple mixing, but everything that has to do with thermal processing, with special, let's say, additional features beside of just homogenization. Then we started with battery business in 2009. I was bringing up this business completely with my colleagues from the sales. We was quite successful to supply lots of, let's say, lab mixes to German universities, R&D institutes like Fraunhofer. And by this, we also learned a lot how to operate our machines, how are the needs or what are the needs of the different applications on anode side, on cathode side. Today, I'm still responsible for the test center, where we're doing the customer tests together with my team of almost 15 people. As you have seen already during our tour, this is the main success point for Eirich, not just to provide a piece of steel. Of course, at the end, we are supplying machinery and equipment, but to show our customers how we can solve their problems.
So you're pushing innovation, and with that, I would like to ask you, what is the key innovation of Eirich?
the key innovation is how to use our mixer, and this is our core element. So, as you have seen in our Mixium, we have invented planetary mixers in 1907. We have invented the Eirich mixing principle in 1924, so almost 102 years old. And Eirich is still relying on just this one mixing
Mm-hmm.
principle. And our key innovation is to bring this in two different applications. So you will find the Irish mixer in almost all applications, even today in pharmaceutical industry, in chemical industry, food industry,
Mm.
and also in battery industry. But beside of those, in foundry, in building materials, in fertilizer industry. So there are almost no limitations how to use these machines. And this is our key innovation: how to make let's say to make this machine work with different kinds of application.
Mm-hmm. One thing that
Mm,
really stands out when you are coming to Hartheim
mm,
here is the merger
mm,
of tradition and technology. And you already mentioned, just in a brief note, but I
mm,
noted it and
mm,
I'd just like to pick it up. You invented the planetary mixer, but those who are knowledgeable about the Eirich process, you're not building planetary mixers anymore. Can you explain that? So you invented this technology, which has become a standard in battery slurry production, but you kind of went further. So what brought you to this next step and also to this, this forefront work
mm,
on creating a new process where you think obviously
mm.
that it's superior?
Yeah, let's say when you're starting with an idea and technology like with a planetary mixer, and you operate these machines, and it was mainly used, for example, in building materials. And of course, we sell machine to different customers, but also we was using here machine to make, let's say, concrete elements here for the local people. Then you learn the pros and cons of these systems, and we learned that the planetary mixer work, but it has its limitations.
Mhm.
And out of this, the second generation of the Eirich family invented the Eirich mixer with a rotating mixing chamber and eccentrically mounted rotor tool to overcome the problems of the planetary mixer. And as the system was so superior to the planetary mixer, it doesn't
Mm.
make sense at all for us to build this other kind of machinery, because if you have the better solution, why you should offer then the worst solution? Huh?
Yeah, for the folks around
Mm,
us that
mm,
ask themselves now, what is he talking about? Meaning, what are the drawbacks that you see, and try to be obvious, of
mm,
course, in a planetary mixing system versus the Eirich one? If you should shine
mm.
light on it from a scientific point of view.
So the key point or the key element is typically if you have a mixer with a static mixing chamber as the planetary mixer, the mixing tool has to do two jobs. First of all, transportation of the material within the mixing chamber.
Mhm.
Secondly, to do the mixing. As this is coupled, you are limited in the parameter settings. So if you, for example, run your, let's say, main tool faster and faster, then it's centrifuging all the material to the outside. You will dig a big hole in the center and your material movement will collapse.
Mhm.
So this means you are limited in the speed of this equipment, typically on 2-3 meters per second tip speed. But this is then not good enough for many mixing tasks. So if you have very fine powders, like in a battery application,
Mhm.
you need high shear force. It means high speeds to open up all these agglomerates to make a good slurry. And this is at the end and the limitation of this machinery. This is why the planetary mixer is adding then a DESPA tool to add some more energy, some more shear forces, but not working all at the same time. This is
Mhm.
so the machinery is limited in its performance, and while the Irish mixer is almost unlimited in its performance. And this is our work as process engineers to understand how we can use our equipment in these different kinds of applications. We develop processes with our customers.
Mhm. So
Mm,
can you explain the principle that you're using and also with regard to the battery industry now? So for one,
mm,
from the technological point of view, technical point of view, so how does the system work? You already
mm,
mentioned it, the
yeah.
rotating chamber, but what are the key aspects that make it so innovative? And what are the implications from that? Meaning what are the unique value points that you can also convey to the customer?
Mm. Yeah, the special is really the transportation, or you have independent parameters. So first of all, the chamber is transporting the material, and it's transporting to the material to a tool which is outside of the center. So it's always bringing the material to the tool.
So you have a bucket, so to speak, right?
Yeah.
And then you have a mixing tool, which is kind of positioned in
in
somewhere.
in the way
Yeah,
of
not in the middle.
not in the middle. It's always in the way of the material.
Yes.
The tool diameter is always 50% of the chamber diameter, and this also makes the scale up so easy because the machines are geometrically the same whether you go for a EL1 Nano with a 100 milliliter scale,
Yeah, that's
or
really
if you
cool
go
to
for a
see.
3000 liter machine with 2.4 meters in diameter. Doesn't matter, geometrically the same, and so you can control torque on the tool, and secondly you can, let's say, have the same material movement inside of the machinery. And this is the secret behind scale up, that this principle can be scaled because of the geometrically identical situation.
So we are always talking about scale up here
Mhm.
in Europe right now, or even ramp up at the
Yeah.
moment, right? So trying to build up large scale processes. And as we know, we are not doing a very good job at the moment in order to be successful to deliver battery cells fully made in Europe on giga scale. When I hear you saying the parameters in relation to each other stay constant, does it also be able to, or is it also to be scalable in an analogous way from a rheological point of view, meaning for controlling the fluids? As I know, you're able to dry mix. Also, we are seeing more and more dry coating, but also, of course, processing traditional slurry. But is the Eirich process in this regard scalable linearly, so to speak? So that you can transfer the research knowledge that you also have seen in the lab today all the way up to the gigascale?
Yeah, definitely. This is, let's say, one of the key, it's the experience we have over 33,000 machines we have running in the field, not only in the battery industry, of course, but also in other industries.
Yes.
We see that if we do everything the same, even on a larger scale, means we have same geometrically, let's say, designed machine, we have same filling level, we take the same, let's say, speeds and settings, that we can get the same product quality, because you have to, let's say, energetically the same energy input into the product, specifically on mass or on volume, and by this you can then easily scale up. And this is also what, let's say, research institutes like BLB, for example, figured out. Okay, this technology, let's say, transfer of scale up, it's an energy point of view. You have to add the same specific energy into the material to achieve the same product quality. And we can make sure with our system that we can introduce the same specific energy, whether in a small machine or in a large machine.
So that's one aspect on achieving the quality that we need. But there's also another aspect to it, and that is timing. So critical voices say, wait a second, the Eirich process is not a continuous one, whereas the coating that comes after the mixing is a continuous one. So you have a problem there. So this is one thing I see. And the second thing I see or I hear, what about time? So are you as fast as the current gold standard? And is it as economical? So can you tackle these two critical voices?
Yes, of course. Let's say we know, okay, coater is always continuous. What you're operating beforehand doesn't really matter, because at the end you have to supply continuously to the coater. And
True.
even if we have a continuous, let's say, double screw extruder, he typically needs in between buffer tanks, which are operated in a batch wise for degassing, for storage, to overcome some interruptions or problems. We have taken this, let's say, technology, say, as a base for our Conti feeder technology. So we prepare batch-wise, store it in a tank in between, degas, make qualification, and then send it continuously to the coating line. For the end user, it doesn't make any difference whether he has a continuous system in front or whether he has a batch system. Second point is we are very quick, so we can produce just in time. And this is a big difference to a planetary mixer. A planetary mixer typically needs to prepare binder solution. Then he has mixing times of 6 to 8 hours. And then he needs also degassing, transfer, and so on. So more or less you need a day to produce one, let's say, batch of slurry and then transfer it. We make it within an hour. So you start dosing, you feed the material, you have, let's say, a mixing time of roughly 20 to 30 minutes. You transfer the material into storage tanks, take your sample, go in lab, make your quality assurance, a proof, okay, quality is as same as let's say your standard or reference, and then you just send it to the coating line. So
Mm.
within 2 hours, you, let's say, start a batch process and you have the slurry on the coating line. And by this, you also can, let's say, order by demand. So the coater is giving the need and you produce in the background batch by batch. And with a batch process, you can much better control the quality as in a continuous process. If in a continuous process you have any dosing problems, then the, let's say, continuous extruder is not capable to overcome this. You have to take out the material, you have to stop somehow the process and to restart or to bring it back. In a batch process, you can check the quality before discharging. We can do this inline with our tool, let's say running like a viscometer, and by this, we make sure that only qualified slurry is leaving our machinery. And as you can operate quite quickly, you can, as I mentioned, let's say, produce on demand.
Yeah, while in the conti feeder, the material is still stored in order to feed the coating line. You can do the measurements, do the verification or the validation that the slurry is at quality to be transferred over to the conti feeder, right? And I see another point, and that is track and trace. So by having a batch, you exactly know this is this charge or this batch, and this is the next one. So it's also in terms of traceability of and performance metrics of your production line a handful tool to operate in this way.
Yeah, and we're tracking anyway all the data during a preparation process. Means you know exactly which raw materials are going in. You need exactly or know exactly how much liquid is going in, which solid content is inside of the equipment. You see all the parameters over the processing time. So you typically have the curves which are representing like a fingerprint your process. And by this you can see, okay, batch by batch is looking quite same to make sure that it's absolutely stable. And this is also a big difference to a planetary mixer. Planetary mixers, they are losing material in the chute to where the raw materials are going in. They are losing material sticking on the planetary gear drive. So they have typically to stop minimum once per week to dig out all the cakings and all the material they're losing within the machine. We have high pressure liquid injection systems which are cleaning the machine with the liquid we have to add anyway during the preparation process. So we have a quite stable process, and we have seen in our gigafactories operating mainly in Asia that we have very stable and very, let's say, accurate viscosity curves, solid content and parameters so that the coating is much easier than with fluctuating materials.
Yeah. Before we come to the entrepreneurial point, these are all the pros of the of the concept and the technology that you deliver. From your own perspective, if you look at the critical voices and if you would try to be as honest as you can, what are there drawbacks, serious drawbacks, or would you say this is not what our process is for? Is there anything that you would like to name to differentiate?
For now, we have not seen any limits. So whether you go for, let's say, any kind of chemistry, LFP, NCM, silicon graphite anodes, sodium ion batteries, there was no limitation. At the end, what we have to adapt is our cooking recipe. So the sequence, the settings within, let's say, the process to make it work with different raw materials. And this is maybe also a strong point because you can adapt this quite easily. So let's say typically our work in the test center with our customers, we have to show up within typically one day that we are able to produce an excellent slurry minimum as good as a reference he is having from his own development.
Okay. So that was from the perspective and shining light on the technological part, right? I think we understood now what the system is about and how it is used and what the performance metrics are that make it successful. Let's look at it from an entrepreneurial point and understand the role of Eirich within the battery ecosystem and also with the customer relation. During our lunch break, Stefan Eirich made an interesting statement and mentioned the word slurry supplier. I think he didn't meant it like word by word that Eirich is now becoming a slurry supplier, but what it was kind of elegantly saying was that you're working so closely with the customer that you could become a slurry supplier. So can you explain this?
Yeah, I think slurry supplier or solution supplier is maybe the better word for
Mhm.
this. So we are not just offering a piece of steel as in form of the mixer and maybe a control system that the customer is able to do something on his own. We understand how we have to operate our machinery. We are, let's say, building the complete ecosystem around our machine. So from powder handling, powder dosing, the mixing itself, all necessary parallel equipment like pump skids, tank skids, conti feeder supply lines up to the coating line.
Mhm.
So we, at the end, we have just, let's say, a pipe with a certain diameter where we connect to the coating line.
Mhm.
And we are offering this complete solution. We install the solution, we train the people, we show them how to operate with our equipment in the best way, how to, let's say, make the best slurry out of our system. And we have lots of parameters where we have the freedom to optimize everything. And if the customer wants to change over from maybe NCM chemistry to the LFP chemistry,
Mhm.
he just has to bring in a new set of parameters,
Mhm.
not a new equipment, not nothing new, just a different set of, let's say, parameters he has figured out in the lab beforehand in excessive trials, because you not just only look on the viscosity of a slurry, you just have to look on the electrode performance.
Mhm.
And so you can easily change then the parameters and make also a different kind of product.
Mhm. Okay. So I understand if I speak on the shop floor technical now, how you are dealing with this, because the Conti feeder needs to operate and connect with the coating line,
Mhm.
right? In order to be steered, to be managed,
Yeah.
to be operated. Maybe we take this as an example on industry collaboration within our field,
Mhm.
because this is something I see very important. The battery expedition as such was built in order to build these bridges to make
Yeah.
one team. Can you explain how you are building up
Mhm.
those collaborations?
Yeah, of course. One word to the Conti feeder. Conti feeder is typically designed for really gigafactories, large scale capacities,
Mhm.
because it's, let's say, somehow expensive to make all this direct piping and pigging systems and so on. And typically, if you just want to produce a certain amount of slurry, it's you are just filling the line, not no material is coming out at the coater. So typically you have two ways to do it. Let's say transfer it into, let's say, movable tank,
Mhm.
where we, let's say, collect the slurry from the mixer, move it to the coating line, connect this tank to the coating line, and then, let's say, start coating. Here, for example, we have in many, let's say, of our projects, we have the company Mattis behind us with coaters. And the main question is, of course, in this moment, so when we transfer the slurry tank, which was monitored and operated with our control system, who takes care on this parameters? I mean, running the stirrer, let's say, checking the filling level
Mhm.
inside,
Yeah.
making all this. Who's doing care on this in the room? Next room where our control system is not located anymore. And for example, with one customer, we decided that Mattis is taking over the control of our tank
Mhm.
within his control system. So we exchanged the information on which sensors are installed, how to operate our equipment. So he had full control of the tank, and also he could track the tank during his coating to have a full picture of what was going in, what was coated, in a report at the end for the customer.
Mhm.
So this is, let's say, kind of collaboration to define, let's say, the transfer not only of the slurry as a viscous material, but also how to communicate between different kinds of equipment from different suppliers.
Yeah.
And this is what the customers at the end looking for. He don't want to take care on what is in between. He's
Yes.
buying a mixer and he's buying a coater. Until nobody takes care on what is in between.
Yeah.
Uh,
He wants this was the biggest
uh,
buzzword the last years, I think, turnkey
uh,
solution.
mm,
Everyone was looking for the turnkey solution supplier.
uh,
And this is a hands-on
mm,
example that you kind of, from an, as I said, entrepreneurial
mm,
level, how it
mm,
manifests on the operative level.
mm,
So what does collaboration in
mm,
this regard mean? And that
mm,
brings me over to the key three
mm,
questions that I ask every guest on this campaign that is entering the bus here,
uh,
the battery expedition vehicle. And there are the
mm,
challenges, the potential, and your call to action and collaboration that you
mm,
see. So let's start with the challenges. I mean, we are in
mm,
Europe, 2026. the Gartner
mm,
cycle is in our heads,
mm,
and we're kind of in the valley right now in terms
mm.
of giga factory ramp up. What do you see are the challenges that are holding us back on really succeeding and making the breakthrough in Europe?
My impression or our main challenge is that um, we have not enough experience in, let's say, supporting customer and operating the plant. So in Asia, we have lots of gigafactories running already since many years,
Mm.
but let's say Asia is a little bit far away.
Mm.
We have lots of pilot facilities here in Europe. Problem of pilot facilities is they are not running 24/7.
Mhm.
So they are just running maybe for a batch, maybe for a certain campaign of a few batches or a few days, one after the other. One example is, for example, UK Big in Coventry, UK,
Yeah.
which is doing so. But if you just make a few batches, you cannot learn about the problems which may occur in a full-scale operation 24/7. So what is your yield, let's say permanent yield? Are you facing problems with, let's say, stationary conditions which are different when you have a cold machine or a hot machine
Mm.
after a certain period of time? How often you have to maybe to clean or not to clean your machine in between? So these are, let's say, practical impressions. You can only collect data in a full scale operation. And when we see also our customers, how long it takes to ramp up such a factory. So Irish is even, let's say, finished with a startup after a few days, but it takes up to a year or even longer until the plant is running, and then still the complete factory is running. The factory is not running on full capacity.
Mm.
It's only running on part of capacity.
Mm.
And so you cannot really collect all the necessary data for OEE level, which our customers are asking for, or for, let's say, scrap rates. So
Mm.
this is, let's say, the experience typically is also with our customers, and they are not sharing it at the end, because if they are better than someone else, they are, let's say, in a favorite situation that they can, let's say, build their batteries a little bit cheaper. So
Yes,
this
of
is our
course.
main problem for European suppliers, that we don't have enough, let's say,
Data
r-
or
data
knowledge?
and knowledge from
Mm.
real full scale permanent production.
Okay. But we're
Mhm,
still believing in Germany, I think.
yeah,
That's
mhm,
what I hear from all the discussions I had, and many
mhm,
people, many of our the executives that I talked to said like there is potential in believing in
mhm,
Europe and that Europe will be successful
mhm,
one day in building
mhm.
these gigafactories. What is, from your perspective, the potential that you would build on?
I think we have here in Europe, and especially Germany, because it's process technology, let's say industry,
Mm.
let's say very traditional, like Eirich, for example. We have, let's say, built thousands of mixes, thousands of plants in different industries, many of them running 24/7. So we have lots of experience starting new technology in in different applications. Why should we not be able to, let's say, transfer to the battery industry? It's not nothing special. Huh?
Mm.
You have, of course, some specialties you have to follow because of, let's say, cleanliness or others, but it's not so special that we cannot handle this. We have to get the chance to do it. So typically customers, oh, I buy cheap from China or Asia because all it's approved technology. They know how to do it. But we see in reality, like with let's say ramping up gigafactories, it takes even years until they are able to start up even approved technology from Asia because of different problems. And I'm quite sure the European and German machine manufacturers, Irish, Sauer Essig, or others, they can do it because they have learned it in other industries which are even more challenging than battery industry.
Mm. Okay, I
Yeah. Mm,
understand. So, if I would ask you
mm,
for one advice
mm.
to your call to action to solve this puzzle, what would you give?
At the end, we would be, let's say, need a, let's say, end user
Mm.
which is willing to test or to use this technology in cooperation or collaboration with the supplier to bring it forward.
Mm.
This is, let's say, one of the key points, because we are not able, even if we are building up here our, let's say, own Giga Odenwald 2 for, let's say, the core element to check some test. The raw materials are so expensive that you cannot run this in a continuous operation. We cannot make then electrodes, we cannot make cells out of this, we cannot earn money with at the end we would then be a battery maker. So at the end you need some customer which is willing to install European equipment, to operate this European equipment, and I'm quite sure at the end he can become much better than the Asians, because if you buy just Asian technology, you will never become better than the Asians. We're always behind in know-how and knowledge because we don't have the long-term experience like the Asians have. So if you take exactly the same equipment, how you want to become better, if you always, let's say,
Do the
years
same.
behind.
Sure. Understand you. Yeah, and maybe your call to collaborate as a final note. What do you say?
Yeah, we are already collaborating with, let's say, in different ways. For example, we was part of the ProLit project for doing dry battery electrode. The outcome was, let's say, a white paper how to set up a gigafactory of 1 gigawatt hour with, let's say, German technology. So from Sauer Essig, from Eirich, from Coperion, together with Ibutech as raw material supplier, with, let's say, universities like the Meat Battery Research Center or BLB in Brunswick. It was quite successful. So this was one part of the collaboration, and Eirich is doing this also further with further, let's say, projects for the future, German funded, but also European funded. Secondly is a collaboration together with, let's say, downstream equipment suppliers, calendar suppliers, for example, for dry battery electrode, as we have seen the test today in the test center, where we was showing, okay, how we make dry battery electrode fibrillated mix. We work together with, let's say, companies like Mattis to let's say, set up, let's say, a solution where the end user don't need to take care about, let's say, transfer of material. So this is always, let's say, a way of collaborating already in the past. We don't want to be a turnkey solution provider to say you have one source where you can buy a complete electrode manufacturing. But we know that we have partners or collaborators where everyone knows his part of the system quite well. We know each other. We know what are the needs of the downstream equipment supplier in view of, let's say, handover of material, but also quality of the material. And so we offer, let's say, a problem-free solution for the end customer at a very reasonable price.
Okay. So I'm looking forward to explore more opportunities in Europe where we can bring this technology in, the technology you provide, all the other peers of our industry provide, of course, the partners of the Battery Expedition campaign. And yeah, with that, I think we just keep pushing, right?
Yeah.
Stefan, thank you very much for the conversation.
Simon, thank you very much for the conversation.